attendance only at the end. So let me join after first half. Is it that?
The problem is very lengthy, ma'am.
Hmm. What is very lengthy?
Problem.
Oh, you are telling about the data mining problem, huh?
Yes, ma'am.
Yeah, decision tree problems are bit lengthy, Anirudh. What to do? You need to work it out. Anyway, I'll extend the time till Monday. I want all of you to work it out and then understand what's
Each problem
happening.
goes up to 5 to 6 pages at least, ma'am.
Yes, yes, it goes to 5 to 6 pages. So you have to. It will be asked in the part B or part C. But then for exam, will be asked a smaller problem, or at least few steps will be asked. At least one or two iterations, or a few will
Ma'am,
be worked out
had
for
it been
you.
offline examination, would you allow us to carry a calculator, ma'am?
Yes, offline examination you can carry calculator, not an issue because you need to calculate the log and other things. If not a calculator, I think logarithm table or book or something would be provided. Some device will be provided to
Okay,
you to
okay.
look into and work. Definitely, you don't worry regarding that. Okay, fine. So where did we stop in the what algorithm did we discuss yesterday's class? Hmm? Yesterday we discussed about C4.5, right? C4.5. So, I mean, 2 days back we discussed about the first algorithm ID3, which uses entropy or information gain. Just a second. Entropy or information gain. So our objective was to reduce the entropy or maximize the information gain. Okay, so that was our objective. Then second algorithm, what we discussed was C4.5. So that is basically a modification of your ID3 algorithm. So here we basically make use of what is called your gain ratio. Gain ratio. So gain ratio is nothing but a normalized information gain attribute. Whatever we used in ID3, it is being normalized. That's when we call it as gain ratio. Okay, so we introduce. The normalization is being done by computing another small factor called split information. Okay, split information, and then you calculate the gain ratio, and then you select the attribute with the highest normalized gain. Okay, as the splitting attribute. So that's how we proceed with C4.5. Okay, so these were the respective equations, the algorithm. Okay, so the procedure is the same except the splitting criterion. Okay, so this was the problem which we discussed in yesterday's class. Okay, so today we'll move on to the last algorithm. What is the last algorithm? Can somebody tell me what is the last algorithm? Hmm? Can somebody tell me what is the name of the last decision tree algorithm to be discussed in today's class? Hmm? Nobody knows. Or nobody wants the person who knows also to share the response in the class. Is it that way? Hmm? So today we are going to discuss about what is called CART algorithm, C-A-R-T. Okay, so CART stands for classification and regression trees. Okay, the CA is basically for classification, RT is for regression. Okay, so in case the predictive feature, that is the target feature, is categorical, then you construct what is called a classification tree. And in case the target feature is continuous, okay, then you construct what is called a regression tree. So together we have coined the name called CART. Okay, so this is basically a multivariate decision tree learning algorithm. Okay, so this can be used for, as I just mentioned, it can be used for both categorical and continuous value target variables. Okay, so in the sense, your CART algorithm will solve both classification problem as well as regression problems. Okay, so now let's see what is the splitting criterion as far as the CART algorithm is concerned. Do you remember? Hmm? I had given a brief regarding what are the splitting criterions which are being used by the popular decision tree algorithms. So this makes use of the concept called what is called your Gini index. Okay, so Gini index, just like gain ratio, we have something called Gini index to construct the decision tree. CART makes use of this particular splitting criterion or splitting and splitting criterion. So this is actually, you can see the formula is being mentioned here. Okay, so this is actually calculated by subtracting the sum of the squared probabilities. You can see 1 minus sum of the squared probabilities of each class from 1. That is, but that's what you can see here, 1 minus something. Okay, so you can see here the pi. So pi is actually the probability of that element being classified for a distinct class. Okay, it's basically, it will denote the probability that it is written down what pi stands for. Okay, so the probability that an element is belonging to or it's being classified into a distinct class. Okay, so the thing to be noted here is this Gini index will assume a binary split. There is only two binary split for each attribute. Okay, so therefore every attribute, whatever you are considering, it is being considered as a binary attribute. Binary attribute in the sense that attribute will be getting split into two subsets, or you can say two data instances. So let's say S1, S2. Okay, so that's how Gini index considers it. Okay, so I mean it basically assumes a binary split on each attribute. So every attribute is being considered as a binary, I mean it is being split into two subsets, S1 and S2. Okay, so this is the formula for it. And okay, so this is how you compute the Gini index. Okay, Gini index for each of the attribute and also for the subsets of each attribute in the training set. Okay, so you can make a note of this formula. Okay, so how it is being computed, just like how you computed the entropy for each attribute t comma a. Okay, t was a target variable, target attribute, and a was a specific attribute under consideration. Same way you can compute the Gini index for each attribute and also for the subsets. I said no, the attributes, it's being considered as binary. It's being divided into two subsets, S1 and S2. So it will be computed for the subsets of each attribute in the training set. Okay, so this basically this Gini index. Okay, so this Gini index is basically how many number of data instances are there for a class, or it is the proportion of instances, you can say. Okay, so it will construct the tree as a binary tree by recursively splitting the node into two nodes, that is two binary nodes. Okay, so even if there is an attribute which has got more than two possible values. Okay, so this Gini index will be calculated for all the subsets of the attributes, and the subset which has got the maximum value will be selected as the best splitting attribute. Okay, for example, I'll show you an example. What happens? So, okay, so in case if an attribute, let's say A, the attribute A is having say three distinct values. It's having three distinct values, say A1, A2, A3. Okay, it's having three distinct values. Just a second. Okay, A1, A2, and A3. Okay, so what are the possible subsets? Okay, so when you say the possible subset, null set will also be one subset of it. Okay, then A1 can be one subset. Same way, A2, A1, A2, A3 is another subset. Then what are the other possible subsets? A1, A2, A1, A3, then A2, A3, A2, A3, then A1, A2, A1, A3, A2, A3, then all the three, okay, A1, A2, A3, okay. So in case an attribute is having three distinct values, as how I have shown here, so the number of possible subsets will be 2 to the power 3. which means 8. Okay, if you exclude the empty set and even this full set, this is, you can say this is not a subset, it's a full set, a1, a2, a3, and even this null set if you exclude. So 8 minus 2, you will be having six subsets. Okay, so you can form three possible combinations. That is a1 with a1 a2, or a1 with a1 a3, or a3 with a1 a2, or whatever. Okay, so hence in this particular cart algorithm, you need to compute the best splitting attribute, best splitting attribute, and again the best split subset, okay, in the chosen attribute. Okay, so then again, the splitting subset with the minimum Gini index will be chosen as the best splitting subset for a particular attribute. Okay, so again, this is as far as the subset is concerned. But again, the best splitting attribute will be chosen by the minimum Gini index, just like your gain ratio, which means minimum Gini index means maximum variation, that is delta Gini, because it reduces the impurity. Okay, so just like how you did for your information gain. Okay, so that is delta Gini of that particular attribute will be equal to Gini index of the target attribute minus the Gini index of the specific attribute under consideration. Okay, so higher the Gini value, higher will be the homogeneity of the data instances. Okay, so Gini index calculation I had shown you. Okay, I had shown you here 1 minus sigma pi square and what it stands for. Okay, so for each attribute, how many ever distinct values it has. Suppose it's having three distinct values, a1, a2, a3, how I just showed you. Basically, you have 2 to the power 3, 8 instances, 8, but then you ignore the empty set and the full set, which means you have 6 subsets. So you can form three possible combinations. Three possible combinations. Okay, three possible combinations when I say, what are the three possible combinations with the 6? So one can be a1, a1 with a2, a3. This can be one combination, a1 with a2, a3, or a2 with a1, a3, a1, a3, or it can be a3 with a1, a2. Okay, so these are the three distinct combinations, three possible combinations which I can form. Okay, so you need to compute the best splitting attribute and the best splitting subset, subset I, from that particular chosen attribute. Okay, so that's what the concept of Gini index is all about. Okay, so now okay, so now coming to the cart algorithm. Okay, so cart algorithm. So this I have shown you what the splitting attribute is, splitting criterion is, and how it is being calculated. So the Gini index, just like you have your entropy, information gain, or your gain ratio for the other algorithms, out here it's being treated as a binary attribute. Okay, binary splitting attribute, and the subsets are also being considered. How it is being considered also I just showed you. Okay, so the best splitting attribute will be the one with the minimum Gini index, or the one with the maximum variation, delta Gini, something which reduces the impurity. Okay, so now coming to the cart algorithm. Okay, cart algorithm. So this so initially what you do is, you compute the Gini index using this particular equation for the whole training set, training data set. Okay, so using this particular equation. Okay, then after that you start computing the Gini index for each of the attribute equations, for the subsets, because subsets are there, S1 and S2 of each of the attribute in the training data set. Okay, so that is by using this particular equation. Okay, so S1 and S2 are the attributes. Okay, subsets, not attributes, the subsets of the attributes. Then after that what you do is, you choose the best splitting subset which has got the minimum Gini index for an attribute. Okay, then you compute delta Gini equation. Okay, that is Gini index of the whole training set minus the Gini of that specific attribute. Okay, so you compute delta Gini equation for the best splitting subset of the attribute by using this particular equation. Then you choose the best splitting attribute that has got the maximum variation or minimum Gini index. Okay, so the best split attribute with the best split subset is placed at the root node. Then after that, here the difference is the root node will be branched into subtrees, two subtrees, not into many nodes like your ID3 algorithm or your C4.5 algorithm. Here the root node is being branched only into two subtrees, with each subtree an outcome of the test condition of the root node accordingly. So the training data set is being split into two subsets. Okay, so recursively you apply the same procedure for the remaining subset of the training data set with the remaining attributes till you reach a leaf node, or there are no more training instances available in your training data set, available in your subset training data set. Training data sets in the sense your subset of the data set. Okay, so that's what your algorithm tells you. Okay, so now let's work this out. Okay, let's work this out in using cart algorithm. So basically the decision tree algorithm construction principle is the same for all algorithms, be it ID3 or your C4.5 or cart. Only the selection attribute splitting criterion alone changes. Okay, so based on that the splitting attribute is being decided. Okay, so okay, so I told you what is Gini index. So regarding the value of this Gini index, again, as usual, for just like the other splitting criterions, whatever we have seen, the value varies from 0 to 1. Okay, 0 means all the elements belong to a certain class, or only one particular class is there. Okay, whereas in case it is 1, there is Gini index varies from 0 to 1. Okay, 0 means same class. It's everything is allied to a certain class, or only one class is there. Okay, whereas Gini index is equal to 1 means all the elements are randomly distributed across the various classes. Okay, so if it is 0.5, 50-50 means it is uniformly distributed into some class. So that's how the interpretation for the value of the Gini index goes. Okay, so now let's look into the problem. Okay, so we'll work out the same problem. Okay, so somebody pointed out that the problems are too very lengthy. Okay, so yeah, decision tree problems are lengthy, but for the next classification technique what we are looking into, it is not that lengthy. It is only the decision tree algorithms problems are a little bit lengthy. So but then please work it out. I will share the PPT today in GCR, and work out all the three problems. The same problem, what I have just displayed on the slide right now. So the same thing has to be worked out using your all the three algorithm, ID3, C4.5 and CART, and submit as an assignment on Monday. Okay, so just simply don't copy from, I mean, one person doing and the remaining people copying from there. So you put in some effort and do it on your own. You have doubts, you can ask me in the next class. Okay, so now let's work this out using our CART algorithm. Somebody has some concern? Okay, so now, yeah, you take the training data set, what is being given here, construct the decision tree using the CART algorithm. Okay, CART algorithm. So what was our data set all about? Assessing the student's performance during the course of study and predict whether somebody is asking me something. What is it? Could you post the assignment for CART algorithm separately? Okay, Anirudh, I'll change the due date also. You can put all the three on Monday. Fine, I'll post another one. Right. Okay, so assess the student's performance during his course of study and predict whether a student will get a job offer or not in his final year of course. Okay, so the training data set is consisting of 10 instances. You can see 1 to 10. 10 instances are there with the attributes CGPA, interactiveness, practical knowledge, and communication skills. Okay, so the target class attribute is nothing but the job offer. So this is the target class. Okay, so what is the first step we are supposed to be doing? By now, everybody should be knowing. What is the first step to be done? Jevora, what is the first step to be done?
Ma'am, classify, like, compare the job offer, like,
Yeah, with
for
respect to the.
everything.
Mm. So you need to calculate the Gini index. Okay, so Gini index for for the data set, the training data set, which is consisting of 10 instances. So the target attribute is job offer, as he said. Okay, so in job offer, how many instances of yes is there, how many instances of no is there, you try to identify that. I think it's 7 and 3, 7 yes and 3 no. Okay, so using the Gini index formula, 1 minus sigma pi square. Okay, so you calculate it as 0.42. Okay, after that what does the algorithmic second step tell you? Second step tells you calculate the Gini index for each attribute of the subset, for the subset of each attribute in the training data set. Okay, so for that, what do we do? Okay, so you need to compute the Gini index for each of the attribute and each of the subset in the attribute. Okay, for example, if you see CGPA. Okay, so CGPA, how many categories are there? CGPA, how many categories are there? This is one category. Greater than or equal to 9 is one category. Then greater than or equal to 8 is another category. Less than 8 is another category. So totally we have three categories. Okay, so totally we have three categories. So three categories means 2 to the power of 3, that is 8. But then empty set and full set you don't consider. So 8 minus 2, 6. So 6 subsets are there. And so three combinations. Three combinations. So you make a table. Okay, so with the three combinations, these are the three combinations: greater than or equal to 8, job offer instance is equal to 3 yes, and where instance is equal to no. Okay, so accordingly mark the count for it. Okay, so then compute the Gini index for the various combinations, the subset combinations. Okay, so subset combinations. Then finally, okay, so this is the table which shows you the three subsets of CGPA, the various combinations. I showed you, no, the various combinations, These are the various combinations, 1, 2, and 3. Okay, so you compute the, it is little bit lengthy. Okay, you compute the Gini index of all these things separately. Okay, then after that, the same table is being shown here. Okay, so how do you select which is the best splitting attribute? Okay, so the best splitting attribute is the one which has got the lowest Gini index or maximum delta Gini index. Okay, so we have not calculated delta Gini. Okay, so that variation. So this is the one with the minimum Gini index. Okay, so that is okay, so you choose the best splitting subset which has got the minimum Gini index for that attribute. So the subset CGPA with this combination, that is greater than or equal to 9 comma greater than or equal to 8 and with less than or equal to 8. This is the combination which we have selected. Okay, so that has got the lowest Gini index with the value 0.1755. So that will be chosen as the best splitting subset. Okay, so now, so then after that you compute the uh, delta Gini or the best splitting subset for that particular attribute. So that turns out to be 0.2445. Okay, so now we have done this only for one attribute, CGPA. Okay, so the same procedure. Okay, so it will take 6 to 7 pages. Okay, so repeat the same procedure for the remaining attributes in the data set. What are the remaining attributes? You have uh, interactiveness. Okay, interactiveness, practical knowledge, communication skills. Okay, for all the three you need to repeat the same procedure. Okay, so when you do that, I think after the first iteration CGPA will be on the top of the root. Okay, then in the second iteration, based on the second iteration or third and other things. Okay, so this will be the final table what you will get. Okay, so in the assignment please write the remaining steps. Okay, and come show me how you're getting these values. Okay, so this is actually the Gini index for all the attributes. Okay, so CGP already was computed. This one, it's on the root after the first iteration. Then you compute the Gini index for interactiveness, practical knowledge, and communication skills with these other respective values. Okay, so from here you can see that communication skills has the highest uh, delta Gini value. Okay, 0.21. 0.21. So the tree is further branched based on the attribute communication skills. So here you can see all the branches end up in the leaf node, and the process of tree construction is completed. Okay, so now I'm not going to elaborate the remaining steps or anything. Okay, we have elaborately done the other two algorithm. So I have shown you one step and how it is. You do the remaining iteration. So this should be the final tree what you are getting. Okay, so this should be the final tree what you're getting. CGPA less than 8 means there is no job offer. CGPA greater than or equal to 9 and greater than or equal to 8, and communication skill is good and moderate, there is a job offer. Communication skill is poor means there is no job offer. Okay, so this should be the final decision tree. So we can easily extract rules from this decision tree. Okay, so okay, so and that's regarding your cart algorithm. Okay, then uh, we discussed only about the CA part, classification. Okay, so regarding the regression part, okay, so since it is just mentioned in your syllabus as decision tree induction algorithms, I think we have discussed three algorithms. So I'm not going to discuss this regression based algorithm. Okay, so the regression tree is actually a variant of the decision tree, uh, where the target feature is a continuous valued variable. You know the difference between classification and regression. I had given you a number of examples. Okay, so if it is a regression tree, okay, so then it can be constructed using an algorithm called reduction in variance. Okay, this I'm not going to discuss now. I felt it is not necessary as a part of a syllabus. Okay, so which uses basically the concept of standard deviation, to choose the best splitting attribute. So just keep this alone in mind. What is the RT, in cart stands for? Okay, fine. So now just a second. Fine. So now we have discussed all the various uh, algorithms, and now let's try to compare the various attribute selection measures. Okay, let's try to compare the various attribute selection measures. Okay, so what are these attribute selection measures meant for? What are these attribute selection measures meant for? Hmm?
Selecting the best split attribute.
Ah, yes, very good, Nitishri. Okay, so it's basically used to select the splitting criterion. I mean, the best split. Okay, the best split that will separate the given data partition. Okay, so if it is ID3, if it was ID3 algorithm, okay, so then the measure was entropy, entropy or information gain. We can see here information gain. Okay, so information gain is actually entropy before splitting minus the entropy after splitting. That subtraction was done, so that's how we computed the information gain. Okay, so information gain is actually based on the decrease in entropy after splitting the data set based on a particular attribute. Okay, so the basic concept of constructing this decision tree, it's all about finding the attributes that has got the highest information gain. Highest information gain means your lowest entropy. Okay, then if it was C4.5, okay, C4.5, it was all about gain ratio. Okay, so gain ratio, as I said, it was nothing but a normalized information gain. Okay, so normalized information gain of the attribute is what is called your gain ratio. That is by computed by the ratio of the calculated split information along with the information gain for each attribute. So that's how you compute the gain ratio. So then the highest gain ratio, that is the attribute with the highest normalized information gain, that is the highest gain ratio, will be selected as the splitting criteria. Okay, then when it came to cart, cart, this is the third one. Cart correlation and regression trees algorithm, we made use of Gini index, and I said it is basically for multi-valued attributes, multi-valued attributes. Okay, then again, the value varies from 0 to 1 and all, I have already told. 0 means it belongs to one class, 1 means elements are being randomly distributed, and 0.5 means it's being uniformly distributed 50-50%. Okay, so as a compare, and it it's mentioned that information gain is biased towards multi-valued attribute, and Gini index also the same. Okay, it's got difficulty when the number of classes is large. Okay, so as a conclusion I can say that this Gini index and your information gain, these two things, okay, so they are used for the analysis of real time scenarios. Okay, so the data is real, that is being captured as a part of your real time analysis. Okay, so when it goes by the definition, the numerous definitions, generally when we look into the books we see it as the impurity of data, or how the data is being distributed. So that's the reason why we calculate which data is taking less or more part in the decision making. Okay, so that's how we interpreted, or we basically go with it. So that's regarding a comparison of the various attribute measures. Okay, of course we have other attribute selection measures also, because we have algorithms like CHAID, CSEP, or G statistic. Okay, those who are, MDL, minimal description length, another thing, that's a principle. Simplest solution is preferred principle. Okay, so there are other popular decision tree measures also. Those who are interested can look into it. Okay, so this CHID guide, I don't remember the full form for it, you will have to look into the net. Okay, or do a Google search. So it's basically a popular decision tree algorithm which uses chi-square test. Chi-square test, uh, uh, and this CSEP performs better than information gain and Gini index in certain cases. Okay, and G statistic has got a close approximation to the chi-square distribution. Okay, and some research aspects are also being mentioned here. So you can look in, those who are interested can look into it. So cart basically finds multivariate splits based on linear combination of attributes. And if you ask a question regarding which attribute selection measure is the best, okay, so the thing is, all are equally good, nothing is significantly superior than the other. Okay, most of them gives good results. Okay, so that's what I wanted to tell you. That completes your topic on decision tree. And now when I take attendance, I want you to do a small work. I want all of you to be doing this. Okay. Can you see a crossword being put here? Are you able to see? Yes or no? Nobody can see, yeah?
It's visible, ma'am.
Oh, yes. Okay. So please start working this out. I think except the 12th one. So 12th one, uh, it comes as a part, but then since it was not mentioned in your syllabus, I didn't mention about it. Other than that, I think everything you can uh, answer in this. I want you to take a sheet of paper, draw the same structure and work out. Let me see who will get the answers first. Okay, so this particular question, Occam's razor, states that the complex solution is dash than the simpler solution. So what it says is Occam's razor example. So what it says is the answer that requires fewest assumption is generally the correct one. That's what Occam's razor principle tells you. Okay, so other than that, you can go ahead with answering all these questions. Okay, so you can start now. Let me take the attendance in the meanwhile. So by the time I finish attendance, Answers should be ready. Answer your attendance. Anirudh,
Present, ma'am.
okay, let me. I'll show you. Wait. Right. You can start doing right now. I have forwarded the same to your WhatsApp group also. So you can refer there also. Okay. This is a classwork coming under the category of classwork. Okay. So Ganirudh is present. What about Dharini? Dharini? No response. Ramharini? Is it that I am not able to hear or all these people are absent?
You are audible, ma'am.
Okay, so these people are absent. Fine.
Ma'am, I think there is an OD list from White Hackers.
OD list. Okay, then I'll just put a dot here. I'll check the OD list and accordingly mark
Okay,
the
ma'am.
ones who are not there in the class. Right, fine. Okay, there's a workshop happening. Okay, you continue. 05 Ram Harani is also not there. Kalyan Sundar also OD. Okay, Aravind 17. Aravind, you are never regular to the class. Why?
No, yesterday I had some internet problems.
Yesterday was internet problem. Day before yesterday you didn't have internet problem. Again on first you had internet problem.
Day
So,
before, not I attended.
Yeah. First you had internet problem. 31st you had internet problem. 25th, then 10th, 9th, 2nd, 9th of August, 3rd of August. So which part of the country are you staying? Aravind?
Yes, ma'am.
Which part of the country? Chennai?
Yes, ma'am.
Which part of Chennai is facing such a severe internet problem that makes you lose this much of attendance? 1, 2, 3, 4, 5, 6, 7 classes?
I'll attend from.
Please take care of your attendance.
Yes, ma'am.
I think all parts of Chennai are well connected with all the good network providers. So don't lose your attendance and thereby lose your marks. Sharan Varghese? Sharan Varghese is there, because okay.
Ma'am, am I audible, ma'am?
Yes. I am able to hear you because I'm not keeping track of the chat window. Why? Because this, okay, Selva, I saw your list here. So as I call, you please tell me. Okay, 03 is OD. 05 is also OD. 15 is also OD. Okay, 20. Sharan Varghese, okay, just mentioned now. Okay, 22, Shakti Priya is OD. 23, Nishok. 23.
I'm present, ma'am.
Okay,
I can't.
present.
Low voice.
Okay, no problem. Shreya,
Present, ma'am.
Suvetha, 30 is OD. Okay. 33, Vishal Bhashyam.
Present, ma'am.
M. Srimati. 35, okay, OD. 37, Kamini Nityashri, also OD. Okay, 41, Pranav Ram.
Present, ma'am.
Pranav, getting the answers?
Yes, ma'am.
How many did you get?
I'm doing across and I'm on the last one in across.
Okay, good going. Proceed. (46) Srimati, yes.
Present, ma'am.
Raja Singh. 49 is also OD. 50 is OD. Okay. 54 is also OD. 56 Nityashri.
Present, ma'am.
Okay. 59 Sriram is OD. Then 27.
59 posted in chat box, ma'am. He's not on OD actually.
Oh, okay. Marked him. What about Likita? 27 is also OD. Okay. 60 Satyamohan. 60 is also OD. 63 OD. 67 OD. Oh, ODs are more than the presentees in the class today. Yeah? Okay, 67, 70, 68, Hemavartini. Okay, Hemavartini, 71. 71 is also OD. Okay, 74 Akshata Saha also OD. 80 Karthik Balaji OD. 83 Santosh Kumar.
Present, ma'am.
Yes. So you didn't want to go on OD. Your name is coming in both the places, OD list and in the class.
Ma'am, my word isn't confirmed, ma'am.
Okay. So you were just testing waters to see which is good. Workshop is good
Yes,
or
ma'am.
class is good. Okay.
Yes, ma'am.
115 Anand Arun. Yes, present. Are you working out the problem? Anand, put in the chat window. Yes, ma'am. Okay, fine. 116 is OD. Present, ma'am, not OD. Okay, good, Rahul. 117, Suhashini Srikanth.
Present, ma'am.
Okay, no energy to tell present. Didn't have breakfast. 118, Apurva Ravichandran. No, it's OD. Then 119, Vithun. Okay. Vithun, how many did you solve now? How many solved? Put in the chat window. No response. Okay, 120, Adityan.
Present, ma'am.
Okay, solving across. Okay, 121, our piece of a rep,
Present,
right?
ma'am.
Okay, rep is present. 122, Ramcharan. 122 is there in the OD lister? No, absent. Yesterday also absent, today also absent. Okay, 123 was OD. 145 is OD.
Ma'am, present, ma'am.
Oh, present and OD, fine. So Pavitra Shri, 147.
Yes, ma'am. Present, ma'am.
Pavitra finished, Pavitra?
Yes, ma'am. Doing, ma'am.
Doing. Then 49. 149 is
Present, ma'am.
Praveen. Okay. Rakesh. Rakesh, 171. Is Rakesh texting something? Rakesh, 171 present. Rakesh is also another frequent absentee in the class due to have networking issues, connectivity issues. What, Rakesh? I can see 1, 2, 3, 4. So many absent against Rakesh. Rakesh doesn't want to share. Then Nityashri Narasimhan, 01. Nityashri? Is nobody telling? Okay, present. Okay, noted. Nisho Katiraven.
Ma'am, he has OD, ma'am.
Okay, OD, fine. Abel Prashant.
Present, ma'am.
Okay. Preetika.
Present, ma'am.
Kevin Kurian Joseph. Present, ma'am. Kevin finished. I'm going to ask you the answers. See, somebody write it in the sheet of paper. I want you to share the screen and share the answers. Let's see who finishes first. The one who finishes first, can we give him one extra mark for the next cycle test, Anirudh?
Definitely not.
Anirudh has agreed, so I'll go ahead.
No, ma'am. I'm in disagreement.
Disagreement, eh? Oh, okay. 45, Hiten.
Present, ma'am.
Okay. Adya, 51.
She texted in chat, ma'am.
Okay, good. Noted. Jay Vora.
Present, ma'am.
Yes. Kishore.
Present, ma'am.
Sridevi. Present. Yash Rai. Present. Jayesh Kumar.
Present, ma'am.
Jayesh finished, huh?
Doing, ma'am.
Doing, huh? Okay. So who has got the answers, all the answers? I'll stop my screen sharing. Who is ready to share the screen and show me the answers now? I don't have the answers for anything. You have to share the answers now. Who will do that? Okay, since you are not telling, I will call out some number. You share the screen and give me the answers. Otherwise, just like +1, there is a -1 also. Okay, I'm not asking you to show me the entire set or anything. I just want to see how much you have attempted and how many answers you have got. Okay, so I'm going to stop sharing and okay. So can Sridevi share the screen and show me the answers? Sridevi? Yes, Sridevi. Share the screen and show me how much you have completed. Today, if you don't respond, my response also will be negative. I'm going to make a note of all these people. So Sridevi is not going to respond today. Haven't done yet, ma'am. So not even one you have started? You have not started at all. Is it? So such students also no attendance today. Today I'm going to seriously take it up because I'm having enough with this class. Whatever I ask, I get a negative response. So that cannot continue further. So let me make a note. So let me make a note. Even if it is 1, it has to be shared and discussed in the class. So 61 from C section will be marked absent. You have a choice, either 1 mark less from the next CT or absent today's class. It's up to you. Okay. From C section, who has completed? Anybody who can share this screen and show me? Kevin Kurian Joseph.
Ma'am, I have not yet completed, ma'am.
It doesn't matter, Kevin. Just show me how much you have completed. That's all. Just share the screen and show me how much you have completed. I know it's not that easy to complete. Just share the screen and tell me how much you have completed. Are you going to do that? No. Okay, that means students are not doing. I am simply projecting. So 40 also no attendance today. Then who can volunteer and do from A section? Somebody can volunteer. Completed. Any of the Nitishrees has completed? Anybody
I
has?
haven't got a few answers, ma'am, but
80% is over. 70%.
yes, ma'am.
Can you share? See, when I ask you something, it's to the others in the class. It has to be done. Not necessarily the complete one, at least a partial. Nityashri is trying to share the screen and show.
1 second, ma'am.
Yeah, sure. So definitely due consideration will be given for her. So I can see people simply leaving the class after giving the attendance. I'm making a note of all these things. Whoever is leaving before the class gets over. Okay, Nitishri, I think the time is up. Next class, come with all the answers and we'll discuss in the next class. I think it comes up in the next week. Am I right? Okay, thank you, Nitishri, for volunteering. We'll take it up in the next class. You have another class too, right? From 11:40 to 12:30, you have a class. So let me not make the other staff wait.